Hey everyone, and welcome back for another deep dive. Today, we're going to be looking at genetics,
Yeah.
but from a slightly different angle, I think, than we normally do.
Yeah, it's an interesting one for sure.
It is. And I'm really excited to kind of dig into this and see where it leads us.
Me too.
So, we're going to be talking about dog breeding eugenics and genetic
Yeah,
engineering.
that's right.
And we're going to kind of see how all of these things are related and how they've kind of impacted each other over the years.
Yeah, it might seem like a strange combination at first glance,
Yeah.
but, by the time we get to the end of this deep dive, you'll see how these topics are actually very closely related.
Yeah.
And understanding that connection will help us understand the power and responsibility we have as we unlock the secrets of our genes.
Absolutely.
Yeah.
So let's start with something I think we can all relate to.
Okay.
Dogs.
Sounds good.
I mean, who doesn't love dogs?
Yeah, everyone loves dogs.
But have you ever really, stopped and thought about the sheer variety of dog breeds that are out there?
Right.
I mean, we got these tiny little Chihuahuas and these massive Great Danes and, fluffy Pomeranians
Right.
and sleek Greyhounds. And it's like a canine carnival out there.
Yeah, it really is remarkable how much diversity there is
Yeah.
in the dog world.
Yeah, and it's all, I mean, it's crazy to think that all of this, from those, stubby little legs on a dachshund to
Right.
the, giant mane of a Bernese mountain dog,
Yeah,
it all came from wolves.
that's right.
Yeah.
Yeah, ultimately all of these different dog breeds can trace their ancestry back to wolves.
Yeah, so you're saying that every single dog breed, from the, the tiniest little lap dog you could imagine to, those giant drool machines,
Right.
they all came from wolves.
Yeah.
That's kind of mind-blowing to me.
It is pretty amazing when you think about it.
So how did we get from wolves to this incredible spectrum of canine companions?
Well, basically humans have been shaping dog breeds for millennia. We see evidence of distinct dog breeds
Mm-hmm.
in ancient Egyptian art dating back 5,000 years.
Wow, 5,000 years.
So, people have been intentionally breeding dogs for specific traits for a really long time.
So were they like the original dog whisperers or something?
Yeah, essentially, they were practicing what we call selective breeding.
All
And
right.
that means that you're intentionally breeding dogs with desirable traits to try to ensure that those characteristics are passed down to their offspring.
Yeah, that makes sense.
It's kind of like, trying to matchmake your dog to create the perfect puppy.
I like that. Yeah, so, you know, I'm guessing those ancient breeders didn't really understand the science behind what they were doing.
That's right.
Like they didn't know about genes and DNA and all that.
Exactly. Yeah, for centuries, dog breeding was really more of an art than a science.
Okay.
People could observe that certain traits were passed down, but they didn't really have the tools or the knowledge to fully understand why
Right.
or how to control it.
So when did that change? Like when did the science part of it all come into play?
So that brings us to the 20th century
Okay.
and the groundbreaking work of a guy named Gregor Mendel.
Okay.
He's often hailed as the father of genetics.
Okay, I've heard that name before.
Yeah, he's a pretty big deal.
So what did he do that was so important for our understanding of genetics?
Well, funnily enough, he wasn't focused on dogs at all.
Oh?
He was obsessed with pea plants.
The pea plant.
Yeah.
Really? What could pea plants possibly tell us about dog breeding?
More than you might think.
Okay.
You see, Mendel meticulously studied how traits like flower color and seed shape
Mhm.
were passed down through generations of pea plants.
Okay.
And through his experiments,
Mm.
he uncovered these fundamental principles of heredity.
Okay.
He was basically figuring out the rules of the genetic game.
Right.
And those rules apply to all living things,
Yeah.
including dogs and us too.
That's fascinating.
Yeah.
But here's what I don't get. If his work was so revolutionary, why did it take so long for people to recognize its importance?
Well, Mendel's work was actually rejected when he first published it.
Really?
Yeah, you see, back then, people thought of biology as a purely descriptive science,
Okay.
but Mendel was introducing math
Right.
and rigorous analysis into biology,
Yeah.
which was a pretty radical concept at the time.
So it was just too far ahead of its time.
Yeah, I think that's a good way to put it.
People just weren't ready for that kind of scientific thinking in biology.
Yeah, they weren't ready for math in biology.
Okay, so his work was kind of buried for a while,
Yeah, it was kind of ignored for a few decades.
but then it was rediscovered.
Exactly.
When did that happen?
So in the early 20th century,
Okay.
Mendel's work was rediscovered,
Hmm.
and it had this huge impact on the scientific community.
I can imagine.
Yeah, this was essentially the birth of genetics as a distinct field.
Wow.
And it provided this missing link for understanding how traits are passed down from one generation to the next.
So Mendel's pea plants provided the scientific foundation
Exactly.
for understanding what dog breeders have been doing for centuries.
That's right.
Yeah.
Yeah, it turns out they were basically genetic pioneers without even knowing it.
That's amazing.
Yeah.
And this newfound knowledge of genetics,
Yeah.
it didn't just impact the world of dog breeding.
Right.
It had a profound effect on agriculture as well.
Absolutely.
And I think I see where we're going with this. So how did we go from like breeding better dogs and crops to something as disturbing as the eugenics movement?
Yeah, so that's a good question, and it's a significant dark chapter in human history.
For sure.
But the connection lies in the application of genetic principles to populations. So at this point, we need to introduce a guy named Sewell Wright.
Okay.
He was a pioneering geneticist who really took Mendel's work and ran with it.
Okay.
He applied these principles to animal breeding, specifically focusing on the complex world of dog pedigrees.
So he was like trying to map out the family tree of dogs.
Yeah, that's a good way to think about it.
What was he hoping to learn from that?
Well, his work went far beyond just tracing lineages.
Okay.
He was digging deep into the genetic makeup of dog populations.
And what did he find?
So what's really fascinating here is that Wright's work led to the development of something called the inbreeding coefficient.
Okay.
And this is a tool for understanding and controlling the genetic makeup of populations.
Okay. Inbreeding coefficient. That sounds a little intimidating.
Yeah, it's not the most user-friendly term.
Can you break that down for us? Like, why would breeders care about this coefficient?
Okay, so imagine you're a dog breeder and you're trying to create a new breed with specific desirable traits.
Okay.
Now, you could just breed any two dogs together,
Right.
but you wouldn't have much control over what traits their puppies would inherit.
Right. Yeah.
And that's where the inbreeding coefficient comes in.
All right.
It helps you understand how closely related the parents are and how likely their offspring are to inherit certain traits, both good and bad.
So it's like a genetic risk assessment tool.
Exactly.
Yeah. Right.
It helps breeders make more informed choices about which dogs to breed
Right.
to increase the chances of getting those desired traits.
Okay, that makes sense. And this wasn't just limited to dog breeding, was it?
No, it wasn't.
This had implications for agriculture as well.
Absolutely.
Right.
Think about it. By understanding these principles, scientists could develop high-yielding hybrid crops and improve livestock breeds.
Right.
And that led to a dramatic increase in food production in the 20th century.
Okay, I see how applying genetics in this way could lead to some pretty amazing advancements.
Yeah, it was a huge breakthrough.
But how did those same principles get twisted into something as horrifying as the eugenics movement?
Yeah, so that's where things take a dark turn.
Yeah.
Sadly, the same scientific knowledge used to improve crops and animals was tragically misapplied to humans.
Right.
The eugenics movement, which gained traction in the early 20th century.
Advocated for the improvement of the human race through selective breeding.
Right.
But their definition of improvement was deeply flawed
Yeah.
and based on prejudice and discrimination.
It's chilling to think about how scientific progress can be distorted to justify such horrific acts against fellow human beings.
It really is, and it serves as a stark reminder that we can never take the ethical implications of scientific advancements lightly.
Absolutely. So this deep dive is certainly shedding light on some unexpected connections.
Yeah.
Who knew that the world of dog breeding could lead us to such a dark chapter in human history?
It's true.
It makes you wonder, are we at risk of repeating the mistakes of the past with all the incredible advancements happening in genetic engineering today?
That's the million-dollar question.
It is.
And it's a question we'll explore as we delve into the fascinating world of CRISPR technology.
Okay.
But first,
Yeah.
let's take a closer look at a specific and particularly chilling example of eugenics in action.
Right.
Vermont's eugenics laws.
You see, these laws were incredibly detailed and actually served as a model for the horrific policies implemented by Nazi Germany.
Wow, that's a pretty disturbing thought.
It is. It's a dark stain on American history and a stark reminder of how easily scientific ideas can be twisted and manipulated for harmful purposes.
It's a heavy thought to carry, especially as we enter this new era of genetic manipulation with technologies like CRISPR-Cas.
Right.
I know you mentioned CRISPR earlier.
Yeah.
Can you unpack that a little more for us? What is CRISPR and why is it causing such a buzz?
So imagine you have this pair of molecular scissors
Okay.
that allow you to precisely cut and paste genes.
Okay.
That's essentially what CRISPR-Cas is. It's this revolutionary gene editing tool that empowers scientists to alter DNA sequences with incredible accuracy.
Wow, molecular scissors for DNA.
Yeah, pretty much.
That sounds like something straight out of a science fiction movie.
It does, doesn't it?
It's incredible to think we have that kind of power now.
It is pretty amazing.
But doesn't that raise some serious ethical questions? I mean, if we can literally edit the building blocks of life, where do we draw the line?
Yeah, that's the big question, isn't it?
It is.
And it's one that we need to be talking about.
Yeah.
You know, CRISPR holds immense potential for good.
Right.
I mean, think about it. We could cure genetic diseases. We could develop revolutionary new treatments for cancer.
Yeah.
We could even engineer crops that can withstand the challenges of climate change.
Yeah.
The possibilities seem almost limitless.
Yeah. It's exciting to think about all the good that could come from CRISPR.
Absolutely.
But I can't help but think about, the potential for misuse as well.
Right.
I mean, we've just discussed how the best of intentions can go wrong.
Exactly.
Like with the eugenics movement. Could CRISPR be used for similar harmful purposes?
Yeah. That's a question that weighs heavily on the minds of many scientists and ethicists. With this ability to manipulate human genes in ways that we never thought possible. You know, we have to proceed with extreme caution here.
It's almost like we're standing at a crossroads.
Yeah, I like that analogy.
One path, leads to incredible medical breakthroughs.
Yeah.
And, healthier future for humanity.
Absolutely.
But the other path, well, it leads to a place where we start manipulating genes for reasons that have more to do with societal preferences than actual well-being.
Yeah, it's a slippery slope.
It is. So how do we prevent that kind of future? How do we ensure that CRISPR is used ethically and responsibly?
Well, that's the million-dollar question, isn't it?
Yeah.
And it's one that requires careful consideration from all of us, scientists, policymakers, ethicists, and the public alike.
Right.
We need to engage in open and honest conversations about the implications of this powerful technology.
Oh, it's not just about the science.
Right.
It's about having those tough conversations,
Yeah.
making sure we have the right safeguards in place.
Exactly. We need to be proactive, not reactive.
Okay.
We can't wait for something to go wrong.
Right.
Before we start talking about the ethical implications,
Yeah.
we need to establish clear guidelines for the use of CRISPR.
Okay.
Ensuring transparency in research.
Right.
And encouraging open dialogue about the potential benefits and risks.
It sounds like we're talking about more than just regulations.
Yeah.
We need a fundamental shift in how we think about genetic engineering.
I think that's right.
It's not just about what we can do, it's about what we should do.
Well said.
Yeah.
We need to foster a sense of global responsibility, recognizing that the choices we make about CRISPR will have far-reaching consequences for generations to come.
Yeah, it's a lot to consider.
It is.
But it's crucial that we have these conversations.
Absolutely.
We've already seen how the misuse of scientific advancements can lead to devastating outcomes.
Right.
We can't let history repeat itself.
We can't.
So this brings us to another crucial aspect of the CRISPR conversation.
Okay.
Who gets to decide what constitutes an acceptable use of this technology?
That's a great point.
Like what's considered a disease versus a desirable trait.
Exactly. Those lines can get pretty blurry.
Yeah, they can. And what might be seen as a flaw to one person could be a source of strength or uniqueness to another.
That's right.
And who are we to say which traits should be edited out of the gene pool? The slippery slope for sure.
Yeah, it is. And it's a global conversation that needs to include diverse voices.
Absolutely.
We need to ensure that decisions about CRISPR are made with input from not just scientists, but also ethicists, policymakers, and people from all walks of life.
Yeah.
This isn't just a scientific issue, it's a societal one.
Absolutely. This sounds like a daunting task.
It is.
But one that's absolutely essential if we want to harness the power of CRISPR for good.
I agree. It is daunting, but I'm optimistic.
Okay.
I believe that through open dialogue, thoughtful consideration, and a commitment to ethical principles, we can navigate this new frontier of genetics responsibly.
It's reassuring to hear a voice of optimism amidst all this complexity.
Well, I think it's important to be hopeful.
Yeah.
While also recognizing the potential dangers.
Absolutely. We've covered a lot of ground today.
We have.
From the fascinating world of dog breeding to the unsettling history of eugenics and the mind-blowing possibilities and perils of CRISPR technology.
It's been quite a journey.
It has, and we've only just scratched the surface.
We have. There's so much more to explore in this fascinating field.
I'm ready to keep diving deeper.
All right, let's do it.
So we've talked about using CRISPR to potentially cure diseases.
Right.
But where else could this technology lead us?
Yeah, good question. The applications of CRISPR go far beyond just treating diseases.
All right.
This technology is already being explored in agriculture, for example,
Yep.
to develop crops that are more resistant to pests and diseases and even climate change.
That sounds like it could be a game changer.
It could be.
Especially with the challenges we're facing.
Yeah.
With, a growing global population and a changing climate.
Yeah. Exactly. And then there's the fascinating world of gene drives.
The gene drives?
Yeah.
That sounds intense.
It is. This is where things get really interesting.
Okay.
And potentially controversial.
What are gene drives and what makes them so controversial?
So imagine you could engineer a specific gene that spreads rapidly through a population, even if it doesn't give that organism a survival advantage.
Okay.
That's essentially what a gene drive does.
Okay.
It's like a genetic chain reaction.
Right.
And it has the potential to completely alter the genetic makeup of an entire species.
Okay, now that's some next-level gene editing.
Yeah.
But I can see how that could be pretty controversial.
Right.
So what kind of applications are we talking about here, and what are the potential risks?
One application that's being explored is using gene drives to control populations of disease-carrying insects.
Okay.
Like mosquitoes that spread malaria.
Right.
By engineering a gene that makes them resistant to the malaria parasite, you could potentially wipe out the disease in entire regions.
Wow, that would be incredible.
It would.
To think we could potentially eradicate diseases like malaria with gene editing.
Yeah.
That's a game changer.
It is, but it's not without its risks.
Yeah, what are the risks?
So you see, releasing a gene drive into the wild is kind of like opening Pandora's box.
Oh.
Once it's out there, it's very difficult to control, and there's the potential for unintended consequences.
So we could end up disrupting entire ecosystems.
Potentially.
Or causing other unforeseen problems.
Exactly. That's why the development and potential release of gene drives is a subject of intense ethical debate.
Right. I can see why.
Yeah, we need to carefully weigh the potential benefits against the risks.
For sure.
Before we even consider using this technology in the wild.
It sounds like we're only just beginning to grasp the full implications of CRISPR.
I think that's right.
It's both exciting and a little bit terrifying.
Yeah.
To think about where this technology could lead us.
It really is. And as we've seen throughout this deep dive, the story of genetics is full of twists and turns.
It is.
We've gone from selectively breeding dogs based on observable traits to manipulating DNA at the molecular level.
Yeah.
It's a testament to human ingenuity.
It is.
But it also underscores the profound responsibility we have to use this knowledge ethically.
I think you've given us all a lot to think about today.
I hope so.
We've covered the history of selective breeding, the complexities of the eugenics movement, and the ethical dilemmas surrounding modern gene editing.
Yeah, it's been a lot.
And it all started with a simple question.
It did.
About how we got so many different dog breeds.
It's amazing how seemingly simple questions can lead us down such fascinating and complex paths.
It really is.
Oh.
And I think that's what makes these deep dives so rewarding.
Too.
We get to explore these interconnected ideas.
Yeah.
And hopefully walk away with a better understanding of ourselves and the world around us.
I completely agree. And as we continue to unlock the secrets of our genes, it's crucial that we engage in these open and honest conversations about the ethical implications of these powerful technologies.
Absolutely.
The future of genetics is full of possibilities, both wondrous and potentially perilous.
Yeah.
It's up to all of us to ensure that we use this knowledge wisely and for the benefit of all humankind.
That's a powerful message to end on. Thanks for joining us on this incredible journey through the world of genetics.
It was my pleasure.
We hope you've enjoyed the deep dive.